Alright guys, today we'll be talking about composite functions. So, you guys should be able to tell me what a composite function is by the end of the day. You should be able to write the equation of a composite function. And I guess that's it for today. We'll see. Alright, so here's a little way to introduce it here. Go ahead and pause the video here, read it, and when you unpause it, I will discuss it with you. So if 1,000 insects are in every acre and there's 10 acres, if there's 5,000 insects in every acre and there's 10 acres, that would be 50,000. And if there are for every 1,000 insects, there's 10 birds. So there's 50,000 insects. That means there would be 50 birds. Okay. So what I'm trying to get you guys to see in this problem is that the number of birds seems to depend on what? The number of insects. And the number of insects depends on the number of acres. So the number of birds depends on the number of insects, which depends on the number of acres. Okay, so this is function language here. The number of birds depends on the number of insects. And the number of insects depends on the number of acres, right? So we have two functions here. Birds are dependent on insects, and insects are dependent on acres. But ultimately, you guys can kind of see that since birds are dependent on insects and insects are dependent on acres, that kind of means that birds are also dependent on acres, right? Because if there's no acres, there's no insects. And if there's no insects, there can't be any birds, okay? And a way that we can kind of show this is instead of putting just the letter I here, we could put I of A there. That means that birds depend on insects, which depends on acres, okay? And that's what we call a composite functions, when you have one function being plugged into or affecting another function in that way. So, what is a composite function? When the output of one function serves as the input of another. Okay? So, well, let's just go through it and then we'll see if we can kind of bring these things to life a little bit. When you plug one function into another, so here's two examples. So, or two functions, I should say. So here we have y equals f of x, and over here we have z equals g of y. Now I want you guys to notice that for function 2, the input y is an output over here, right? So over here the x is an input, the y is an output. But over here the y acts like an output and gives us, well, I'm sorry, I wrote that bit wrong. Over here, the y acts like an input because you're plugging it into the g function, which gives you another answer out. So that's the first thing there. When the output of one function serves as the input of another function, okay? Another way of thinking about that is as though you're plugging one function into another. Okay, so since z equals g of y and y equals f of x, I can replace y with f of x and get this. So when the output of one function serves as the input of another, then that's like you're plugging a function into a function, and that's what we call a composite function. All right? So let's go back to our little story problem there about the birds, the insects, and the acres for a second. The number of insects depends on the number of acres. So that's I equals F of A. The number of insects depends on the number of acres. Now this time I'm writing it a little bit differently than I did last time, but there it is. I'm using F instead of I of A. Next we have function 2. The number of birds depends on the number of insects. That is, B is a function of I. Since I equals F of A, I can replace I with F of A and get a new function that looks like this, where now we could say that the number of birds depends on the number of acres. And that makes sense because the acres has an effect on the insects, which therefore affects the birds. Okay? So that's what we call a composite function. All right, so let's go ahead and take a look at example 1. For example 1, what we're going to do is we're going to just work on interpreting these things in the context of a word problem. So let's go ahead and say that P represents the number of people at a fundraiser. S represents the number of snacks at the fundraiser. M represents the amount of money made at the fundraiser. So we have 3 letters up there that each represent something. And now we're going to look at number 1 here. It says, using the variables defined above, explain the meaning of each expression below. So what this is saying is it's telling us that P is a function of S. In other words, P depends on S. Now, if P depends on S, that means that the number of people at a fundraiser depends on how many snacks are there. So here's, I'll circle the final answer, but here's how you can write it, okay? Here's some ways to think about it. What this first step you can do in interpreting this is you can say P depends on S. But then if we actually talk about what P and S represent, we could say the number of people at the fundraiser, which is P, the number of people at the fundraiser, depends on the number of snacks. Ain't it the truth? The more food you have, the more people come. So, P, the number of people at the fundraiser, depends on S, the number of snacks. Okay? And so our final answer then is going to be this statement right here. So I want you guys to write a sentence interpreting what this means. Okay? Let's go ahead and do part B here. All right. So for part B, we have M equals G of P. So M equals G of P. Okay? And what that means is that M depends on P. But what do M and P represent? M is the amount of money made. So, the amount of money made depends on the number of people at the fundraiser. Space there. And that makes sense, doesn't it? That the amount of money you make depends on how many people would be at the fundraiser if you're there selling stuff. All right. Well, we got a little bit more to do here. So that's part 1. We're just interpreting these statements a little bit. Let's go ahead and take a look at number 2 now. Now, number 2 says, write a composite function using the functions f and g above and explain its meaning. Okay? So, here's what I want you guys to notice, is that the output of this function becomes the input of this function. Okay? And so what we can do is I can replace p with f of s. Okay? And so what that's going to look like is this. M equals g of, not p, but f of s. F of s equals p, so I can replace it with that. All right? Now let's write a statement about that. M depends on, now I'm going to focus just on the s right here, the input. Okay, so M depends on s. Now, over here, M depended on p, but I just replaced p with a function that has s in it, and now that makes M depend on s. And therefore, I can say that the amount of money, the money made, depends on the number of stacks. So, in the last part, what you're going to do is you're going to replace the input with the expression it's equivalent to, and that's going to change how we interpret it. Now, instead of saying that the money depends on the people, which it does, we're going to say that the money depends on how many snacks there are. And the reason we're going to say that is because the number of people actually depends on how many snacks there are, which means that so does the amount of money we make. Okay? So that is what a composite function is, plugging one function into another, and that's how you interpret it in the context of a story problem. So I want you guys to do that for this problem here. Go ahead, read the top, and then do 1A and B as well as 2. Pause the video, and when you unpause it, you will see the solution. Okay, there's your solution there. Let you guys look at that and see what you think. And then we'll move on to something new. So pause the video if you want to look at it a little bit longer. I'm going to erase it. All right. So that we've done the first part of our lesson today, which is just understanding what a composite function is and how to interpret it in the context of a word problem. And since functions can be represented as equations, graphs, and tables, we're going to learn how to work with composite functions with equations, graphs, and tables. And the rest of today is just going to be devoted to how do you work with composite functions when you are working with equations. So right here I'm giving you the equation of two separate functions, g of x and f of x. G of x is 5x minus 3. F of x is 2x squared plus 4x minus 5. You might notice that f of x looks a little weird, but that's because I've made it so that it can do a neat little animation. We're going to create the function f of g of x. So what that means is I'm going to take these two functions and I'm going to create a new function called f of g of x. And I'm going to do that by plugging the g function into the f function. So the first thing I'm going to do is I'm going to take all the x's out of the f function and I'm going to put the g in. Whatever you do on the left side, though, you do on the right side. So everywhere there's an x, we're going to plug that in. And I've created a new function now. Okay, I'll show it to you again. So we take the x out of the f function and we put the g in its place. And since I did that on the left side, we're going to do it on the right also. We take the x's out and we put the f of x or the 5x minus 3 in their place. Okay? So that's what I like. That's our little animation to kind of demonstrate how do you create a composite function out of two other functions when you're given their equations. So let's go ahead and practice this on this example 2 here. I've given us two functions, p and q. For the first one, I want you to find p of q of x, and the next one I reverse it. I want you to find q of p of x. So let's go ahead and I'm going to write some steps here. Now, you don't have to follow my steps, but they kind of help me show my thinking as I teach it to you. So if you want to write it down, though, you can. So the first thing you need to do is you need to make sure you know which one is the inside function. So in this case, my inside function for number 1 is q of x, because it's inside these parentheses of the p function. So the q of x is inside of the p function. Okay. So in this case, my inside function is the q. All right. Now, since I know that the inside function is q, that means I know that my outside function is the p. So the next step we're going to do is we're going to write the outside function. Or actually, you know what? Let's go ahead and start by writing the inside function here. And once again, my steps are kind of a little extra, if you will. And so after you kind of get used to it, you won't need to do all this. But I'm going to say write the inside function. So that's how I'm going to start. I'm going to start by writing the inside function. So I'm going to write q of x and what it equals. Okay? So that's step 2. So identify your inside function and then write out what the inside function is. And then step 3 is going to be write the outside function but keeping two things in mind. You want to write it underneath the inside function. And also you want to replace the x's with parentheses. Okay, so I'm going to write the outside function now. The outside function is the p. I'm going to write that underneath of the q function, but wherever there's some x's, I'm not going to have x's there anymore. I'm just going to put some blanks. Oops. My bad. I think I'm doing that actually wrong. The p function is 2x plus 1, right? So p of x is equal to 2 times x plus 1. So I just rewrote the outside function, but and I put it underneath of the inside function, and instead of putting x's there, I left blanks. All right. The last thing I'm going to do is I'm going to drop the inside function into the outside. And what do I mean by that? I mean I'm going to take this inside function and drop it down into there. And same thing on the other side, drop it down into there. And so now my final answer is going to look like this. Okay, and it doesn't hurt to simplify, but I don't want to focus on that right now too much. I'm going to go ahead and simplify this, but I don't want you guys to worry about that too much at the moment. I just want you guys to make sure that you know how to do these first 3 steps, okay? So identify your inside function, write the inside function down, and then write the outside function underneath of it. But when you do, replace the x's with parentheses. After that, go ahead and just drop everything in. So that's example 1 there that we just did. Let's go ahead and do another one. And as you guys can see, you don't need to write these steps out. You don't have to do every single one of them. Some of you guys might be able to just jump right into the answer, and I'm okay with that. It's just that when I teach it, I find that if I don't actually write these steps out, some people get a little bit confused by what I mean. So let's go ahead and do the next one. So now I'm going to ask questions, and as I ask them, I want you guys to think about the answers. So step 1, identify the inside function. What is the inside function? You have 2 choices, P and Q. The answer is P because it's inside the parentheses. So step 2, write the inside function. So what would I write? You would write this. Just write the inside function. No tricks or turns there. But number 3 gets a little interesting. Number 3 says write the outside function. Now before we go any further, what's the outside function? The outside function is Q. Now, it says write the outside function, but doing 2 things. Put it underneath of the inside function that you just wrote, and replace the x's with parentheses. So see if you guys can do that. So the outside function is Q, and so it's Q of x equals x squared minus x plus 3. So I wrote the Q function, but wherever there were x's, I replaced the x's with just open parentheses there. And now we're ready for step 4. We're going to drop the inside function down into the outside function. So on the left side, this is going to drop down. I'll use a different color. This is going to drop down into here. And this is going to drop down here and here. You're going to put that 2x plus 1 in 2 spots because there were 2 spots for the x. So here's our final answer. Well, I guess it's not technically our final answer, but okay. So there's that. Now, we can actually simplify this. Now, so I feel like we've practiced these steps enough, so I hope that you guys are feeling comfortable with creating a composite function. I think I'll go ahead and I'll write down the simplified answer for this. I'll tell you how to do it, but I'm not going to show you every single step, okay? So the first thing is that 2x plus 1 squared, that means you have 2x plus 1 times 2x plus 1. And you need to do a box method multiplication, which some teachers call the area model, or you could do foiling. It doesn't really matter. You would also need to distribute the negative into this set over here. Okay? After you FOIL this out and distribute the negative, you just combine all your like terms together, and I'm going to write what the answer would be. And that's what you would get if you went ahead and simplified the expression. Okay? So let's go ahead and throw some of these at you guys here. Now, I've given you guys 3 functions. So I'm making you think a little bit more here. So for number 1, you're doing f of g of x. For number 2, you're doing g of f of x. So you can completely ignore this for the first 2 problems. Those are kind of our basic ones. But for number 3, you're going to work with f and h. And the very last one, I get really creative. I'll let you see if you can figure that one out. It's just kind of like a little bonus challenge problem. So go ahead and pause the video here and do as much as you can, and we'll see what you guys get. So here's the answers to numbers 1 and 2. I think most of it's pretty self-explanatory. I would just say that maybe here where you have 1 over x plus 1 squared, what that means is that you have 1 over x plus 1 being multiplied by itself. So you have 1 times 1, which is 1. X plus 1 times x plus 1 is another FOIL method or box multiplication method. Either way, you get x squared plus 2x plus 1. And then we have the minus 1 on the side. The other one's pretty straightforward all the way through, so I'll let you guys study that. And I'll show you, and then just a second I'm going to reveal the next answers. All right, so the last two problems kind of go together here. So let's take a look at number 3 first. So we plug the square root of x in, right? And when you get to this point right here, square roots and squares cancel each other out. So you're basically just left with x there. So you end up with x minus 1. Now, let's go ahead and take a look at number 4. So what's weird about number 4 is that for a second, what I want you guys to do is I want you to just ignore something. Make the pen work here for me. Oop, too big. You ignore this and this for a second. So if you ignore that, f of h of x, we just found that. It's right there. Right? So we already know what that part equals. We did it in number 3. All right? So what's the significance of that? So what I'm going to do then is I'm going to treat this whole thing here like an inside function now. Okay? And that's going to be my inside function. F of h of x is x minus 1 because that's what I got in number 3. My outside function is the red g there, so it's g of x. So I wrote that underneath and I plugged everything in and we get what you see there. So the x minus 1 and the positive 1 cancels out the 1's, and you're left with 1 over x as the final answer. So on your homework, if you come across something where there's 3 of them, what you want to do is just do the do that part first to figure out what that whole thing equals, and then go back and then you can do the whole thing after that. Okay? All right, and I think that does it for our lesson for the day. So until next time, we'll see you then.